All right, boys and girls, welcome back to the drive-through, sponsored by The Deli. The Deli would like to give a shout-out to Devansh. What a great addition to our class that he's been. We're so happy to have him here. Okay? All right, so this is a tough proof. We're going to have to do it in multiple columns because I don't think it's going to fit. Let's see. We are given that EF is perpendicular to CF, and I think we're just going to have to hold on to that for a little while. I think we're not going to be able to use that for quite a while. We know that CE is congruent to DE, and we know that angle FCD is congruent to angle FDC. And we're trying to prove that EF is perpendicular to plane M. Well, this is a great question to ask because we had confusion on this yesterday. To prove that a line is perpendicular to a plane, it is not sufficient to just prove that that line is perpendicular to one line in the plane. You've got to show that it's perpendicular to at least two separate lines in the plane. And that has everything to do with, if I could just draw a plane, I could draw a green line in that plane, right? And I could draw a blue line in that plane that's perpendicular to the green line. So would you admit that the blue line is perpendicular to the green line? Is the blue line perpendicular to the plane? It is not. That should show you that that's why it's not sufficient to just show that it's perpendicular to one line. I've got to show that it's perpendicular to two. So my new goal is to show that EF is perpendicular to FD. And I think to show that EF is perpendicular to FD, I'm going to have to show that triangle EFC is congruent to what? EFD. And then if the triangles are congruent, then I can go CPCTC and show that the angles are also right, and then I can get the congruent, or I can get the perpendicular that way. So that's going to be my goal, okay? And since it's my video, I'm squiggling the givens. Deal with it, people. All right, step 2. I'm going to say that FC is congruent to FD. And the reason is if sides, then angles. No, sorry. If angles, then sides. Does that make sense? So now I've got that and that. And check this out. EF is congruent to itself. Reflexive. Okay. Now I have triangle EFC is congruent to triangle EFD. Okay. By SSS. All right, now here's where it gets a little weird. Angle EFC is a right angle. What's my reason for that? Definition of perpendicular, right? Because it tells us up here that they're perpendicular. Okay? Now I'm going to say angle EFC is congruent to angle EFD. CPCTC. Okay? I'll continue this over here in red so we don't get confused. Okay, so now I can say that angle EFD is right. And remember that if we take out one angle that's congruent to another and place it into a sentence, that's what substitution is. There's a case where transitive would not work, okay? Have to say substitution. Now I can say that EF is perpendicular to FD, and that would be definition of perpendicular. If two lines form right angles, then they are perpendicular to each other. And now I can say that EF is perpendicular to plane M, and my reason is if a line is perpendicular to two distinct lines, bless you, in a plane, then that line is perpendicular to the plane. Boom!